Hello everyone, my name's Louis and I got a ATAR of 99.55 when I graduated year 12 in 2024, and I got a 49 out of 50 in the methods external and an overall mark of 99 out of 100. So a perfect score of 50 out of 50 in the internal exams. And so I'm here to show you how I think about doing these questions and my thought process doing the paper I did last semester, and I guess how to get a similar, even higher score, just walking through that and some tips and tricks along the way. So question 11, part A, with 2 marks. So we need to show basically 2 points that the marker will tick us off in. And so determining the second derivative of y equals x to cubed minus 3x squared. Okay, and so what we can do here is we do the first derivative. So that's probably where our first mark comes from. So that's 3x squared minus 6x, because all we're doing is just taking this power, putting it to the front, and then minusing by 1 as our new power in the derivative function. So that's going to be 3x, 3 minus 1, which is 2, and then bringing this down, this 2 down, so 2 times 3, which is 6, keeping that negative together, and then the power decreases to 1, because 2 minus 1 is 1. And then the second derivative, making sure that we are answering the question, is going to be differentiating the first derivative essentially. And so that's going to be 6x minus 6, because we're bringing that 2 power down, so 2 times 3, which is 6x to the power of 2 minus 1, which is just 1, or just x, and then minus 6x. So whenever we have taken the derivative of anything of x in terms of x, taking the derivative of that will just be the a value, or the coefficient in front of that. Okay, because again, we know that x just has a power of 1. If we take that down, we're just doing just the same thing, timesing by 1. We'll have our same value for the coefficient at the front, but then our 1 minus 1 power, which will be 0, that just becomes ax to the power of 0, which x to the power of 0, anything to the power of 0 is really just 1. And so we're just really left with that number at the front. Okay, so those are just some tricks to keep in the back of your mind to be really quick with these sort of questions. Okay, that's an easy 2 marks. Now basically, using our result from question 11a, calculate the value of the second derivative when x equals negative 1. So quite simply, it's just substituting x equals negative 1. So this is the notation for it, d2y over d2x, where x is equal to negative 1. I'm just essentially putting that in. Wherever there's x, I put negative 1 in brackets. And because it's a tech-free exam, I would show all my working out for that. Okay, just to make sure that I'm not losing any marks unnecessarily. Okay, so this is the first derivative mark in the top, and then second derivative. So especially in tech-free questions, I am not skipping any working out. Right, so this 1 mark question, part B, is really just for the correct answer. Okay, but it's best to not risk it and to just, I guess, skip working out. It's really important that if you've given 4 lines, use as much of it as you can. Okay, so determine the x and y coordinates of the point on the graph y equals x to the cubed minus 3x squared, for which the rate of change of the first derivative is 0. So if the rate of change of the first derivative, that's basically saying the second derivative. So you need to know that that is implied. Okay, because remember, when we're taking the derivative of something, we're talking about getting the rate of change of that thing. Okay, so the first derivative is the rate of change of the original y function, which is this one. But if we're getting the rate of change of the first derivative, then that is getting another derivative, which will be the second derivative. Apologies for that. Okay, so really that first mark, this is 3 marks here. That first mark is literally just saying that d2y over dx squared equals 0. So really just saying that second derivative, derivative is equal to 0. Okay, that's 1 mark, and it's not worth losing that mark just for, I guess, not showing full working out. Okay, so you need to show basically your facts. What is the question asking you to do, and what do you know from that information in the question? Okay, and so we would let our second derivative, which we found from part A was 6x minus 6, let that equal to 0. Okay, and then just rearrange, and therefore x is equal to 1. Okay, and so that is our second mark, is finding the x coordinate of the point. And then substituting into the graph equation, so just say that substitute x equals 1 into y equals x cubed minus 3x squared, because we are trying to find the x and y coordinates of the point on this graph. Okay, so we have to put the x value into this graph particularly. So y equals 1 cubed minus 3, 1 squared. Okay, and so we get 1 minus 3, which is just negative 2. Okay, and so therefore the coordinates are equal to 1 comma negative 2, and that's my x and y coordinates there. Okay, so that is our second mark, is finding that y coordinate. Okay, so the x and y coordinates need to be together in order to fully answer the question. Okay, so that's our 6 marks there. Real quick, real easy, and I think it was a really nice question they gave for 6 marks. Question 12 is a bit unique, and so really requires us to look at and understand the question. So each day over a 3-day long weekend, a family spins a pointer on a circular board to decide whether they will spend the day at the beach or bushwalking. The circular board consists of 3 equal sections. Okay? Determine the probability that the family will spend all 3 days bushwalking. Okay? So we know that the probability that they will spin the wheel and get bushwalking is 1 in 3 chance, because the circular board consists of 3 equal sections, and so this part of the pie chart, you could say, is 1/3 equally subdivided into those thirds. Pretend this is like a pizza, right? And so you have an equal chance of that spinner landing on each of the 3 options, right? And so the probability is 1/3 of a chance, okay? So, but if we're spinning the wheel 3 times each day over a 3-day long weekend, right? That's basically independent probability. And so we need to use our product rule and see that, well, the chances or the probabilities of choosing bushwalking doesn't change every time we spin the wheel. So the probability of 3 bushwalking days is equal to 1/3 cubed. Or in other words, but simply with the product rule, it's just 1/3 times 1/3 times 1/3. Okay, so we're talking about the first day you're bushwalking. So that's a probability that we do bushwalking on the first day, because we spin the wheel on that one day, the first day, and we get bushwalking. On the second day, it's the same probability. We can still have the same chance of choosing bushwalking, okay? Because we're not removing that option or anything. It's just independent probability. Okay, and the same thing with the third day, right? And because all of these are happening simultaneously, as in like where the outcome is simultaneous, as in we are spending all 3 days bushwalking, there's no or function or anything like that, then this is like a and or the product rule being applied here. Okay, because this is basically calculating the probability that we're doing bushwalking on the first day and the second day and the third day, and that and word is really representative of the multiplication between the probabilities. And so that's simply just 1 over 27, because 3 cubed is 27 and 1 cubed is just 1. And we can see that by just multiplying through top and bottom. Okay, so that's our answer, that's our mark. So 1 over 27 is the mark there. Okay, and then moving on to part B. Determine the following binomial probabilities expressed as fully simplified fractions. Exactly 2 days will be spent at the beach. So we know that with exactly 2 days, we can, I guess, know that if we are using our formula sheet, we go to statistics, go to binomial probability, because that's what we're being asked of. Then we are using this equation here, right? So I will probably just rewrite that there as it is, and then I'll figure out what my variables are. So this is a combinatoric or combinations formula on that first part there with the n and r. There's no fraction symbol there, so that's why I know combinatoric, the probability to the power of r, and 1 minus probability to the power of n minus r. Just making sure I got that correct. It's been a while since I've done this. Okay, that's right. So we know that my r value is what I want the number of days to be, especially if we let x equals the days at the beach. Okay, so that makes sense. X equals r, so days at the beach equals 2 days. And then my n is my total number of trials, which will be 3 trials or 3 days at the beach. Okay, and so what happens there is that I can just substitute in probability of x equal 2 is equal to 3 combinatoric 2, and then my probability that I will be spending a day at the beach, so making sure that it's just the probability of a day at the beach, so just of x, so 1 day is, if I look at the chart, it's actually 2/3, because I have 2/3 of my pie chart, or 1/3 plus 1/3, being filled up with that pie chart. Okay, so it's 2/3, and I want that to be 2 days, so I'm raising it to the power of 2, and then 1 minus 2/3 raised to the power of n minus r, which is just 3 minus 2. Okay, over there. So I can put this in my formula. Sorry, I've put it in the formula now, and well, I don't have a calculator, but I know a couple of things that I can solve with combinatorics, and I can work with my fractions. So 2 squared 4, apologies there, 2 squared is 4 over 3 squared is 9, and then 1 minus 2/3. Well, if 1 whole is 3/3, taking 2/3 will be 1/3 to the power of just 1, which is 3 minus 2, so I'll just be left with 1/3. And I know with this 3C2, there's 2 methods I know of solving this. So one is knowing or just memorizing the formula. It's not on your formula sheet, but basically NCR is equal to n factorial over n minus r factorial and times r factorial. Okay, Now factorial is really just a symbol for multiplying all the numbers in integers going down until 1 and multiplying them together. So I might show what that looks like in terms of 3C2, sorry. So that would be, if my n value is 3 and r value is 2, then I have 3 factorial over 3 minus 2 factorial times 2 factorial, okay? And so 3 factorial would just basically be like 3 times 2 times 1, and then 3 minus 2 is 1, so 1 factorial is just 1, I'll just get rid of that, times 2 factorials, which is just 2 times 1, and so I'm just cancelling out top and bottom, and I'm left with 3. Okay, another way to figure that out, 3C2, is if I write what's it called, the triangle, what's that called again? Sorry, I'm searching up proper name for it. It is Pascal's triangle, sorry. Just revising here myself. I know that this is when n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. And so I stop here. Basically what Pascal's triangle is if you don't know it, you can search it up. It's a good thing to look into. Basically I have 1s all over my diagonals at the ends, and then I'm adding the 2 numbers on the top from the left and right to make my middle number, which is like 1 plus 1 would be 2, 1 plus 2 is 3, etc. And so at n equals 3, I just count from, basically this is my r, the columns now, r equals 0, r equals 1, r equals 2, and that's my value there, so 3 is my value. So I have 3 times 4 over 9 times 1 over 3, which is just going to be, I'm canceling my 3's here, so that's going to be 4 over 9 left over. Okay, and so those are my 2 marks. The first mark from showing my formula using the formula sheet by substituting those values in, and then my actual answer. So that's the 2 marks there. And for part 2 of question B, fewer than 3 days will be spent on the beach, trying to find that binomial probability. So for this one, we will find the probability that x is less than 3. Okay, and because we have a maximum of possible outcomes that we have 3 days in a row spent on the beach, then we know that if we want fewer than 3 days, then we need to take 1, which is another, because with binomial probabilities we usually get a fraction, and so 1 is representative of the entire probability. Of all the combinations minus the probability that x is equal to 3, right? Because essentially what we're doing is, if we're trying to find the probability that fewer than 3 days will be spent on the beach, then we're trying to find the probability that 0, 1, and 2 or 2 days will be spent on the beach. And so if we know the probability that 3 days will be spent on the beach, then taking away that from 1 will give us the probability of fewer than 3 days, right? Because we know that the probability that we have 0 days at the beach, 1 day at the beach, 2 days at the beach, and 3 days at the beach is equal to 1, okay? And by doing 1 minus this value here that I've highlighted in yellow. Then essentially we are just getting this section that I've highlighted in green, which is equivalent to fewer than 3 days spent at the beach, right? So essentially we're applying the complement rule here for this question. So that is the first mark is correctly determining the required method. Okay, and then in that case we have 1 minus, and again we're going to use that formula, which is the it's in the formula sheet again, but from the previous part we have combination of n to r, p to the power of r, and 1 minus p to the power of n minus r. So we know that the n value is 3 and our r value is 3 again. Okay, and the probability that will be spent at the beach is 2/3. Again, from that pie chart, to raise to the power of r, which is 3, and times 1/3 raised to the power of n minus r, which is 3 minus 3, or 0. Okay, and so that's our second mark, which is determining the required binomial expression for the calculation. Okay, and then now you can just simplify that. So we know that if the n and the r value when we're doing NCR, or when n equals r, then that will always equal to 1, because we know that from our Pascal's triangle that we have 1s at the ends here. So this is equivalent to n equals 3, r equals 3, this value here in I've highlighted in green. Okay, and we can also confirm that using the formula with the n factorial, n minus r factorial times r factorial. So 3c3, it's going to be 3 factorial of the n at the top, and then 3 minus 3 factorial times 3 factorials are n. So 3 times 2 times 1 over 0 factorial, that's just 1, times 3 times 2, and so obviously that's just going to equal to 1, because we have both the top and bottom being the same. So that basically just cancels out to 1, and then 2/3 raised to the power of 3, so 2 cubed is 8, and then 3 cubed on the bottom is 27, and then 1 over 3 to the power of 0 is just 1, so that just stays the same there. And then again, if you have trouble doing this, that's okay, just make sure you know how to work with fractions. So 1 whole in terms of the fraction over 27 is just 27 over 27 minus the 8 over 27, because now I have the denominators being the same, and I can take away the on the numerator. So 27 minus 8 is 19 over 27. Okay, so that's our probability there. Don't be afraid to make these little side, or on your spare piece of paper, make these side, minuses if you do have trouble with them, So make sure you revise that. You don't want to be losing marks on silly mistakes like subtracting when you've done all the maths correctly for methods that you need to know, right? Especially with these tech-free papers, it's not worth to risk anything there. So that's our full marks for that question there as well. Okay, the third mark obviously determines the probability as a fully simplified fraction, so it needs to be proper fraction and simplified. Okay. Right, next question is we have a function of x, and we need to use integration to determine f of x if f of 0 is equal to 5. Okay, so f of x is already an integral function. Okay, so we just need to integrate every part of the equation here in terms of dx. So In this case, we use our formula sheet if we need to remember, but if we're integrating with e to the x, then it'll just be e to the x, but we know that if we have an a value here, then we're dividing by that a value, okay, in our integral when we integrate. So, and that a value will be given, sorry, the a value is actually here, okay? And so if there's an a value in the power, then we divide by the a value. Okay. So not by the coefficient at the front, but by the number out here. So the a value here is 2, okay? And then same thing with sine, okay? If we have an integral of sine x, okay, but we integrate and get negative cos x, okay? But if we have an a value inside with the x, then we have to divide by the a value. Okay. So let's integrate and find our indefinite integral first before we can make a definite integral using this value. So we can just say f of x is equal to, so for our first term, we have 4e to the power of 2x. Our a value is 2 in front of the x, so we're dividing by 2 now. So just keep everything the same, but divide by that a value. And then we're adding, but remember with integral of sine, we're taking the negative value of cos and keeping everything the same again with what's in the bracket, but we are dividing by that a value. Okay, so that's a value of 2 again. Okay, and plus c. Always remember your plus c. Don't forget. And then now we simplify. So 4e to the power of 2x divided by 2, that's just halving. Okay, so that's there. And then this plus minus becomes a minus, half cos 2x. Okay, I like putting the half on the outside in the front of the trigonometric expression there, because I want to clearly know like my a values and my coefficients as well, rather than keeping this at the top of the fraction can sometimes be a bit confusing, at least for me. Remember your plus c. Okay, so you really, with this 3-mark question, given that there's 2 parts to it, you get marks for integrating the exponential term, and then you get a mark for integrating the trigonometric term. Okay, now we know that f, when we substitute x equals 0, we get a value of 5. Okay, so let's write that fact down. Sorry, f of 0 gives a value of 5. And what I'm going to do now is I'm going to let the f of x equal to 5 when x is 0. So 5 equals 2e, and then I'm basically putting all zeros in where my x's are. Okay, so 2 times 0 minus half cos 2 times 0 plus c, because I'm trying to find that c value now. All right, so 5 equals 2e to the power of 2 times 0, which is just 0. So e to the power of 0 is 1, so 2 left over, and half cos of 0. Cos of 0, I know in my unit circle, is going to be the x value when the angle is 0, and so that's going to be 1, positive 1. So half is left over, and then plus c. Okay, and then really this is just basic algebra, minus 2 both sides, so we get 3 equals negative half plus c, plus a half on both sides, we get c is equal to 3.5. Okay, and so that is our third and final mark. But remember to be fully complete, we need to include that constant of integration, which is c, in our actual f of x formula. So going back to this part here, we just rewrite it. And then we add our c value there, so plus 3.5. And I think they might accept 7/2, but if I were in the actual exam, I think I would have put both the mixed fraction and the improper fraction 7/2, just to give both forms and to not risk losing any marks there for any form or any basic thing like that, right? And so moving on to part B, if dy dx is equal to our function here, we have to determine y. So we know this is a derivative function, and to determine y, we need to have differentiate our dy dx, okay? Because we know differentiating a derivative brings it back to its form, okay? And we need to remember we have a plus c as well, because we don't have any values that are known in this question, and so we need to always remember our plus c. Okay, so I'm always going to make a good note of that and make sure that's really clear there. Okay, but this is quite a complex integral if we just look at it simply as it is. So the key here is really about just simplifying the fraction itself to make it into something we know how to integrate, and we can change this fraction form into an exponent form or power form, okay? And the way to do that is we have two things on the top, but it's by one denominator. And so a trick here is really to separate those two fractions that are hidden within this formula here, or this equation for dy dx. So I'll explain to you what that looks like. So we have 3x to the power of 7. That's one thing on its own, divided by x to the power of 4 minus the 2x over x to the power of 4. So those are two separate things on itself, but it's still the same equivalent thing as what's here inside the bracket, okay? Because remember, if we have the same things on the denominator, then we can just combine the numerators together. But in this case, we want to try and separate them so we can further simplify and make it in a form that we are more comfortable with integrating, okay, such as the exponent power form, as I mentioned. Okay, so now we've done that, we can use our index exponent laws to simplify, right? So we have 3x to the power of 7 divided by x to the power of 4. We know our index law that if we're dividing by the two numbers with the same base but different exponents, then we simply just minus the base, the power from the top and bottom. So 3x cubed plus 7 minus 4 is 3. And then here, same thing, we keep the 2, but the x to the power of 1 here on the numerator minus the x 4, which we're dividing by in the numerator, is going to be x to the power of 1 minus 4, which is negative 3. Okay, and remember, we are squaring that term. So that's an easy mistake to make, but make sure you're always looking at the top line of your working and making sure it's really equivalent to the bottom line, because we have this equal sign. We need to make sure that we're always just keeping everything the same and equivalent, right? So now we've done that, we can say this is a form dy dx. Okay, we've got it into something that it's really nice. And so we now differentiate dy dx. Sorry, we don't differentiate yet. My bad. Because we have that squared on the outside, and so we need to use our binomial expansion or perfect squares formula, which is x plus y, and perfect square of that is equal to x squared plus 2xy plus y squared. Okay, this isn't on the formula sheet, I don't think. But another way you can find out about this is about the Pascal's triangle again. So remember, if our power is 2, then we have our coefficients on this row of n equals 2, right? So 1, and then our 2 is there. And we are basically just doing, again, taking the power and minusing 1 on the first component, and then going up in ones for the second component, which is the y, right? So we have the x squared as the first term. So because y is going to be 2 minus 2, which is 0, right? So it's basically just derived from this binomial theorem here. Actually, yeah, we have that formula, actually. Remember, we have the combinatorics, which is from the Pascal triangle in the previous question, question 11. And so, yeah, that's really, it's question 12, sorry, that's really what we're doing there. So you can derive that, or you can just memorize the perfect square formula, okay? So here, we are now going to apply that formula, 3x cubed, and that's going to be squared. All right, we don't have any of that second term, minus 2x to the power of negative 3 yet, okay? And then because this is a minus, actually, then we are actually minusing the middle term, right? Because we know x minus y squared is actually x squared minus 2xy plus y squared. Okay, so that value is minus, so we make sure we put a minus there. And then we put 2 times the multiplication of the two terms. Okay, so times 3x cubed times 2x to the power of negative 3. And again, the reason I'm not taking that negative is because I already took it in here. Okay, we're not doing a negative again. Okay, if that makes sense. Otherwise, we'll just have a positive value in the middle, and we don't want that. We want a negative value in the middle. So we're just doing that minus there, so we're saving ourselves from making a mistake. We're just taking the x and y values on their own, essentially. Where, you know, this is x and this is y. Sorry. This is y. But this negative here is not part of those xy. They're separate. It's sort of what's between them, if that makes sense. And then we're taking that last component and we're squaring that, okay? So remember, common mistake here is that we just square the x part of the expression, but really we have to square every single part. So 3 on its own has to be squared, okay? Because 3 is kind of separate from the x cubed, if that makes sense. So that's going to be 9x, and then again, using exponent laws, if we're raising a power to an exponent, then we have to multiply those powers together. So x to the power of 6 minus, and here we have, let's just work with the powers first, x to the power of 3 times x to the power of negative 3. Those are just adding those powers together. So 3 plus minus 3 is 0, and so we will no longer have an x component. So we're doing minus 2 times 3 times 2 essentially. We don't have the x's anymore. And so that will be 12. And then with this last component, we have plus 2 squared, which is 4, x to the power of negative 3 times 2, which is negative 6. And then now we're trying to find our determine y from the question, we have to take the integral of that in terms of x, and remember our plus c again. And so finally, y is equal to, and then remember our formula for integration. It is basically adding a power to what we're integrating, and then dividing by what we've just summed, which is the n plus 1 and then the plus c. So in that case, we have nx to the power of 6 plus 1, which is 7, divide by that number, 7, and then minus 12 x, because integrating a constant, we just have x in the front of the coefficient, and then plus 4. So this is a bit tricky one, but it'll actually be a negative here because we have negative values on the power, and negative 6 plus 1 is negative 5, so we're dividing by 5, so 4 over 5 here, and then keeping that power from what we just summed, so negative 6 plus 1, and then plus c. So that is our full marks for that. We get the first mark by correctly expanding the squared bracket, and so that will be this one here, okay? So using that formula for the binomial distribution and applying that, and then simplifying the expanded squared bracket into separate terms is this mark here, and obviously our last mark is getting the correct y in terms of x by integrating all the terms. Okay, question 14, which is 5 marks. So at a particular game at a local sporting venue, 60% of spectators support the home team and the remainder support the away team. A researcher asked 6 groups of 10 spectators which team they supported. Each spectator was recorded as either H, which supports the home team, or A, supports away team. The results were as follows. Okay. The researcher would like to see the distribution of the sample proportions of home team supporters obtained by entering the information into a column graph. The sample proportion for group 1 is shown. Okay. Complete the column graph by including the sample proportions for the remaining 5 groups. Now, when this question came out for 3 marks, it was really a shock to everyone, because this is literally just counting the number of H's for each group. Okay, so very simple. I don't know why this question was on here, but it was just 3 marks. Okay, probably the most simple familiar question you'll get here. All right, so here they've already done group 1, and we can verify that and see what they did. So what they did was they counted the number of H's. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 H's, and because there's out of 10 spectators in each group, and so the sample proportion for home team supporters was 0.8. Okay, and so that's our p hat is 0.8. Okay, for the group 1. Right, and so that has been plotted on the graph as a frequency of 1 for 0.8 sample proportion of home team supporters. Okay, and so we do the same for the other group. So 1, 2, there's 2 H's, so this will be a 0.2. All right, sample proportion. Group 3, 1, 2, 3, 4, 5, so 0.5. And you get the gist of it. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 0.9, and 1, 2, 3, 4, 5, 0.5, and 1, 2, make sure you're counting the H's, 1, 2, so 0.2. Okay, so we know that there are 2 frequencies of 0.2 sample proportion, so I make sure, and I would have a ruler for my actual exam, but make sure you are using your ruler for this graph, and you are drawing that in and you're shading it in very quickly. Okay, remember, don't spend too much side shading or making it look artistic. All right, they want to see your maths, not the artism. Okay, so we've done group 2, we've done group 6. Now we got to do the 0.5, so we know there's two of them. So again, we use a ruler, draw a straight line for the 0.5 sample proportion, and then shade that in very quickly. All right, and then we've done those, and then what's left over is a 0.9, which is just one frequency, so we're just doing a bar next to that, okay, at the same height, frequency of 1. Now making sure, just double check that we've done all the groups. So we have frequency of 2 plus 2 plus 1 plus 1, which makes 6. So yes, we have gotten all our marks there. And so literally the marks, for the 3 marks, make sure you draw 3 bar columns, basically, right? So that was easy 3 marks. Okay, so that's it. And then question B is, if the researcher had interviewed more groups, each containing 100 spectators, describe 2 ways the distribution of the resulting sample proportions would be expected to differ from the distribution shown in question 14A. All right, so we need to describe 2 ways the distribution would be expected to differ from the distribution we have on the graph that we just completed. Okay, so with 2 marks, the first one is saying that the graph will become more symmetrical, okay? Okay, and basically the reason for that is because larger samples will change the distribution of p hat more closely approximating normality. And by that, I'm referring to the normal distribution. So you can just put in brackets like a normal distribution image or figure due to large samples. Or yeah, that's just it. I've repeated myself there. I don't want to do that. So that's really the first mark, is to correctly identify one change to the distribution of p hat as it more closely approximates normality due to the larger samples, which is a more symmetrical graph. Okay, in other words, with our graph here, it's not really symmetrical at all. We can't draw a vertical line through this graph and say that we have a perfect symmetry from left and right hand sides. Okay, because the graph sort of looks like, if we were to draw it, I'll just draw in green. If it was a line like a normal distribution, it would be like more like that. Okay, that is not a symmetrical graph. All right, but a symmetrical graph would have say 0.6 as the mean. So I could probably add here that it will be some more symmetrical about the population proportion. And the reason I say 0.6 is because it's in the question. Okay, so that's a key point there. 60% or 0.6 is the population proportion, as in like, because here we're taking samples, but in the entire population, as a metric, we have 0.6 as our, I guess, mean, as opposed to the p hat. Okay, so the mean population, mean, sorry, of the home team supporters is 0.6. Okay, and so it will show more of that with this mean being 0.6. So it's sort of with more samples, which are more groups, each containing more people, then that's going to make our graph much more similar or representative of the mean values, which is the 0.6. Okay, and the second way, so that was the first way. The second way, sorry, the second way that can change is that along the x-axis of our graph, there's going to be less variability. So you can see here that we have like a lot of frequency at the lower end of the population mean, which is 0.6. Okay, so we have four, I guess, groups that have the sample proportion less than the mean, and then only two groups that have it above the mean. And it's quite far apart, so the variability difference between those are 0.4, and then here the maximum might be like 0.3 here. And so that's a really large variability. I'd say like 0.7 range. And I guess in more complex statistics, we talk about standard deviations as well. So I guess of diagrammatical or like a visual way to explain this is that we are changing our graph from being very variable, so something like this normal distribution, will actually become more I guess narrow in a way, right? So there's less variability. As more samples will be representative of the mean value of 0.6. Graph will be narrower or skinnier, if you want to put it that way. Okay. There should be less high or low sample proportions, like it is currently. Okay, because currently, as I mentioned, there are too many high and low frequencies. In fact, none of the groups represent the population mean. So that's really just a, I guess, inaccurate representation of the mean, because we've only taken 6 groups and 10 spectators, right? But if we take more groups, each containing 100 spectators, we'll go closer to that mean value with less variability and symmetrical normal distribution. Okay, so those are the 2 marks there. And I might add to my first point that the graph in question 14a, or distribution or graph in 14a, is currently not symmetrical. And the reason I say that is because we want to make sure we're distinguishing the difference. That's the key word there, differ, from the distribution, okay? Because what if you lose a mark because you haven't specified that the distribution in part A isn't symmetrical? They might think that it's, oh, what if it's already symmetrical? Like, you need to identify that they will be different. Just like we have said here, like it is currently. Maybe I might be more specific, say question 14a. Okay, so something like that to really show that you know that they're going to be different. Okay, but those are just safety tips there to make sure you get 100% and the full marks for that question. Okay, so that's full marks there. And on to our last simple familiar question for the exam. Okay, so there's usually the 5 simple familiar questions in the question and answer booklet, and then the 2 complex familiar questions, and then the complex unfamiliar questions come as the last 2. Okay, typically it's like that, but sometimes it may vary. Like I think 2023 had 20 questions in total for the paper 1, so that includes the multiple choice and the short response. But yeah. Okay, here I think it was quite simple as well. They gave so question 15, 4 marks. A survey was conducted to understand whether people support a new policy. Using a z-score value of 2, the approximate confidence interval for the population proportion of people who support the policy was calculated as 3/10 and 7/10. Okay, so the margin, we have to determine the margin of error. Okay, so we know that in a confidence interval, we always have p hat minus the margin of error, which is capital E in this case, comma, the p hat or sample proportion plus the margin of error. Okay, and so really the difference between them is going to be when we do our calculation, it's going to be 2 times the margin of error, and I'll show that there. So confidence interval is in that form. Okay, I'll see. I don't think it's in your formula sheet, but I might be incorrect. Yeah, so basically this here is your margin of error. That is your formula. So again, you can remember that or just take that as it is, but remember, because we don't have z, we don't have n, but we have our actual value, then we know we can just calculate the margin of error given our confidence interval. Okay, because we can cancel out the p hats and then get left with the negative e and stuff, right? So this is like similar to simultaneous equations. We know that p hat minus margin of error is equal to 3/10, okay? And p hat plus the margin of error is equal to 7/10, okay? Because we have 3/10 over 7/10 in our confidence interval, and we know that E is our margin of error. Sorry, that's our margin of error there, capital E. Okay, and so if we were to subtract equation 2 minus equation 1, right, then we will cancel out our p hats, and then we get E minus E, which is 2E, the left hand side, and then 7/10 minus 3/10 is 4/10. And then therefore E will equal to basically just half of that value, so we get 2/10 or just 1/5. Okay, so that's our 1 mark there we get, and we now need to determine the number of people surveyed. Okay, so in order to find the number of people surveyed, we need to know a couple of things. One of them is our p hat, because we know n, lowercase n, is our number of people surveyed, so we're trying to find lowercase n. Okay, and if we know that E is equal to this right here that I've highlighted in green, then we can use that formula. Okay, but first we need to find p hat. So p hat plus E, we know that's 7/10, but we know that E is 1/5, okay, over 7/10. And so what happens there is we can minus 1/5 on both sides and make the denominators the same. So that's just a factor of 2, and then just minus the numerators now, and that'll be a half. Okay, so in that case, what I can do now is I know that E is equal to the part of the formula which I highlighted in green there. So that is going to be z square root of p hat 1 minus p hat, and those are multiplied together, over n. Okay, and then my margin of error I figured out was 1/5, and then my z value I know is 2 from the question. Okay, so always go back to the question, and then square root of p hat, which is a half, times 1 minus a half over n. Okay, now I could have transposed it. I'm going to do that after I do this method. So there's two methods to do it. We might transpose the actual formula here in green first, and then for n, and then we just plug in the numbers, or we can just do it with the numbers. So if I want to get n on its own, I need to get rid of, or like undo the actions of the other components. So with this one, I will just divide by 2 on both sides to get rid of the 2 on the outside of this square root. So that'll give me 1 over 10 equals the square root of a half. And then I might do 1 minus a half, which I know is a half. Okay, over n. Okay, and going down to get rid of the most outside component of the right hand side, I will square both sides. Okay, so if I square both sides, then I can get rid of that square root, which is pretty annoying me at the moment. So 1 over 100 equals, and just everything inside the square root now. So half times a half. I might work and say I know that's a quarter, and then that's divided by, so a quarter divided by n. Okay, and now what I can do, I know I have a trick where I can just swap this component and this component. So n is equal to a quarter divided by, and I might put a divided symbol so we don't have too many fractions now, by 100. Okay, and from that I know that my n value is going to be 25. Okay, and so that is the number of people that have been surveyed. So I might, because given this is, a word problem about the policy, I might say therefore 25 people were surveyed, just to be safe and make sure that I'm getting full marks for responding in a appropriate manner. Okay, so that's my last mark, but the 2 marks for my working out, the first one was to figure out what p hat was, okay, because that's crucial for the formula, and then really the next one is just substituting the p hat and z score into the confidence interval. So that's just this one right here. Okay, so that's our 3 marks. And then the second method, where we are transposing the formula and then putting it straight in. So I know that E is equal to Z times the square root of p hat times 1 minus p hat over n. So what I can do is I can divide Z. I'm basically doing the same thing but without numbers, but just letters. So I've divided by Z on both sides. I can square root. Okay, and then I can just swap these 2 components up now. So I don't know which formula you prefer to use, but this is the formula you can plug into. After transposing, you really need to show that working out though, in order to get the marks. But really, that's the formula to use if you want to find the number of people that have been surveyed, right? And so we can sort of see that here where we have the p hat times 1 minus p hat as a quarter, and then the E over Z, which was going to be 1 over 5 divided by 2, which is a tenth, squared that's 100. So we can sort of see that it's, it fits with the equation. So that's how I've transposed it there. I'm sure there's other methods as well, but as long as you get the right answer and you show your full working out, I'm sure you get the full marks there. Right, so that's a full 4 mark there. Let's move on until the complex familiar section. So question 16. The graph is of the form y equals log base a x plus b. A point on the graph 4, 3 is labeled. The line x equals -4 is an asymptote. Okay, so that's our graph. And there is a point P with the coordinates x, p, yp on the graph where yp is twice the value of the y-intercept of the curve. Determine the value of xp. Okay. Now for this question, there are a couple of things we know. So we know there's a point on the graph 4, 3. So that's my x and y value for that I might substitute later. And then x equals 4, x equals -4 here is an asymptote, which means that the line will never, the limit goes towards that line and it goes towards intersecting it, but it will never intersect it. Okay, and so we know that's an asymptote. Okay, and we also know we're trying to find where yp is twice or 2 times the y-intercept of the curve, which is this point here. Okay, so I might make that y-int, but it will also have an x value as well, which will be 0. Okay, because y-intercepts, their x value will always be 0. So we know that's given. Okay, so that's really what we know at the moment. Okay, and we're trying to find the value of xp, however. Okay, so remember, when we get to yp, okay, to get full marks, you need to actually answer the question, find xp. Okay, so we know we're going to be substituting yp back into the formula and everything, trying to find x and stuff like that. Okay, so this really requires us to know and memorize the formula for a logarithmic equation, right? So our a value is the base, but our b value is, I guess, more important to us because that is the asymptote. Okay, and in fact, you need to know though that the the general formula of the logarithmic graph actually is x minus b in the brackets. And the reason I say that is because when you put x equals -4 into this equation, the general formula, then you get your right answer. You get the x plus 4 here in the bracket. However, I'm sure a lot of people were tricked into putting b equals -4 here and then getting a value of x minus 4. But that's not the case because a -4 as a b value will actually shift the graph to the right hand side. Okay, because that's saying that the b value is actually 4, which is a shift to the right, positive right. Okay, but -4, that is our b value, but we need to make sure we are using the general formula. So that's a trick they might put in complex familiar questions. They'll give you something to trick you, but you need to go back to the basics, all right? Complex familiar is really about just sticking to that simple familiar concepts, but making sure you don't fall for their traps. That's how I might put it, okay? So that's the key point there. We know that x equals -4 is a vertical asymptote. Okay, and we know it's vertical because from the dashed line on the graph. And therefore, this is equivalent to a horizontal translation of -4, or in brackets 4 to the left, for the function y equals log base a of x. Okay, and so there we know that in our general formula, y equals log a x minus b, that we know that we are moving to the left, so our b value must be, we must be doing x plus something, or x plus b. Okay, so y equals log base a x minus -4. Okay, so that's the key thing there, and therefore y equals log base a x plus 4. Okay, so we have that in our form now of y equals log a x plus b, which is in the question, and we can say therefore b equals 4. Okay, so really that first mark you get is to correctly determine the value of b in the equation. Okay, so as long as you have, b equals 4, then you'll get that tick. Okay, and you put that in the equation. Right, and then the next thing you do is to substitute a point, because if we want to find what lowercase a is, or our base for the log, but we know the other variables, such as we know what b is, we know what y and x can be, then we can find a. So let's substitute again our x and y values. So 4, 3. So 3 is my y, equals log base a, which is what we're trying to find. It's unknown. And then our x value is 4 plus 4. Okay. And then here, I know 3 equals log base a 8. And you can see here now that in the tech-free paper, I really like tech-free as opposed to tech-active, because the numbers they give you will be very easy to work with. And if you're working with really, I guess, difficult numbers, and you've done everything, you feel like you've done everything right, then you actually haven't done something right. Okay, so if for example, and I'll continue with my work here, a to the when I'm converting logs into exponential form, I take the base, I go around anti-clockwise, which is the power here as a number, and then what's in the bracket comes and becomes on its own on the equation. So this is equivalent to a, which is the base, to the power of 3. So going anti-clockwise on the circle equals 8. Now if my value I got here was 9, for example, and then I get something with a cubed equals 9, and I'm in tech-free complex familiar paper, then I know I might have done something wrong. It doesn't exactly mean that I've done something wrong, but taking this cube root of 9 and trying to solve that, or just keeping that as a exact form, is a bit weird on a paper. So just make sure, maybe you might have done 4 plus 4, or something might have happened that got you a wrong answer. You just need to check your work again. Okay, but really 8 makes sense. I know I'm on the right track because I'm getting these nice whole numbers. So a is equal to 2. Okay, because that's the cube root of 8. Okay, there's no other way for that. Okay, because we need to get a on its own, and to get rid of the cube, we cube root. Okay, and now what we do, so that's our second mark. I can kind of tell that now the next mark is to find the y coordinate of point P. But first we need to know the y-intercept of the curve. Okay, so now that we know our a and b values, we can work with our y and x's now, all right? So y equals log base 2 x plus 4, right? And we know that when x is equal to 0, as we said on our graph, y-intercept is given. Okay, so we let x equal 0, 0 plus 4. So log base 2 of 4 is just 2, because we're trying to find what number can we raise to the power of 2, the base, to get the value of 4, which is 2, because 2 squared is 4. Right? Again, we can confirm that using our, I'm converting it to our, converting it to, where did I go? Our exponent form, and then making the base the same, and then equivalent statements there, y is equal to 2. Okay, that's another way to confirm that we're not messing up here. And at point P then, because our y-intercept is, our y coordinate for the y-intercept is 2, then at point P, we made that formula we did before in the question, yp is equal to 2 times the y-int. So 2 times 2, which is equal to 4. Okay, so we know our yp, that's our third out of the 4 marks. And then obviously our fourth mark makes sense to be our xp value. Okay, so all we do, if we know what yp is on the point P, to find xp, just substitute yp and find xp. Okay, so 4 equals log base 2 xp plus 4. Okay, and then we can convert this into exponential form. So again, taking the base, raising it to the power anti-clockwise way, and then put everything in the bracket is equal on the right hand side. Okay, and then going down 2 to the power of 4 is 16, or if you don't remember that, just do 2 times 2 times 2 times 2 and go that way, xp plus 4, and then minus 4 on both sides to get xp. Okay, and so that is our fourth and final mark, right? So again, because in a tech-free paper we get these nice numbers, we know that we've done something right. Okay, we can be more confident. And I guess it also makes sense on the graph if you think about it as well. If we extend this graph where our y-int is 2, then maybe our yp might be here at 4, maybe double that distance from here to 0. Okay, if we were to continue the graph, then it makes sense that, because this, I guess, this graph plateaus as x increases, so we can sort of see why it'd really be quite further along the x-axis and x equals 12. I think I've done my 4 a bit too low there, but you see what I mean. Like, we can make a good estimate from the graph as well, because I think it doesn't say not to scale, so I think it's scaled pretty well here. All right, so let's move on to the next question. 3 marks. Question 17, all right, is to a community group that uses social media create a new post on the internet on a day when they had 1,000 members. The rate of change in their number of members, which is, the units as members per day, is given by the derivative function f-t equals 3e 0.5t, where t represents days after the new post. Determine the time it will take for the community group to achieve 7 times the initial number of members. Express your answer in the form ALNB. Okay, so note that we'll be working with ln and forms of that. So don't freak out if you have like freaky numbers like an ln value, because we need to keep those exact values, right? Don't try and calculate or round or anything like that. Keep it in exact form, as we do in tech-free papers all the time anyway. right? So there's two methods that the QCAA gives. I'll take a crack at this question without looking at the answer key and just see maybe if this, because this was my paper last year, and just try and work on it. So what I do know is that when t is equal to 0, my f of t, or I guess f of 0, is equal to 1,000 members, because time is t, and when the new post was created, then that is, t, that's 0 days after the new post. So that's what t represents here. Okay. And so I know it initially had 1,000 members, right? But we're given the rate of change of that. Okay. So we need to integrate, right? Okay. So I'll just rewrite that derivative formula there. Okay. And so from here, I would probably integrate in terms of dt, in terms of t, sorry. And I know my a value here is 0.5. And so if I'm dividing by 0.5, I'm basically trying to get double the number on the front. So I know that's going to be 6e, and keep everything the same there, to the power of 0.5t plus c. Okay. And then from that, I know currently they have 1,000 members, so that's what I've mentioned here. Then therefore 1,000 is equal to 6e to the power of 0.5 times t, which is 0, plus c. So I'm now trying to find my c value because I'm moving from indefinite integral to definite integral. So 1,000 equals 6e to the power of 0 will just be 1, so just 6 on its own, plus c. So c is equal to 994. So therefore f of t, so my general function there, is that there. Okay. And now what I need to do is I need to figure out the time it will take for the community group to achieve 7 times the initial number of members. So 7 times the initial number, which was 1,000, is just 7,000. Okay, so I can say that there. So 7 times 1,000 equals 7,000. Okay, so that will be my ft that I'm trying to find here. So 7,000 equals 6e to the power of 0.5t plus 994. Okay. Okay, and then, oh, this is a interesting one. So they actually made us do 7,000 minus 994 in our own working. So you don't have to do, obviously, this sort of working out like arithmetic. You can sort of just go, oh, okay, so it's 994 is almost 1,000, so 7,000 minus 1,000 is 6,000, but I need to add back the 6 that I subtracted too much from, because it's 994 I'm only subtracting, so I can sort of make it that it's 6,006 as my number. So I think that's sort of what made it complex familiar, I think. But honestly, I don't think this is too difficult if you're confident with your arithmetic. But if you wanted to see how I do it on the side here, then I just make sure if the top number is smaller than the bottom number, then I just put a 1 there. make that 6. And if there's a 0 here, I make that 9, but I make sure I make the number on the left, I take 1 from that, but if it's also 0, I make it 9, and then obviously 7 will be 6. So 9 minus 9, that works, okay? 0. 9 minus 9, again, that works, 0. And then 6 minus nothing is 6. Okay, so again, that confirms it's that 6006, okay? But I guess we all have our different ways of working through it, so as long as you get the answer right, it should be okay. So completing the, basically it's just basic algebra, honestly. So divide by 6 on both sides, 1001. So how I did that so quickly, I know that I guess 6,000 divided by 6 is 1,000. So if 6,006 is just an addition of 6, so 1 6, so that would be 1,000 plus 1, 1,001. Or I can look at it in my head and go 6 divided by 6 is 1, 0 0, and 6 divided by 6 is 1. So what I did in my head is basically just long division, I guess. So 1, 6 divided by 6 is 1, 0 0, 1. I guess. So whatever way that works for you, it's up to you. Right, and then we know that we can get the power down by taking the log of both sides of the base, okay? So we take the log of E of 1001, and we also take the log of e to the power of 0.5t. And now I can use my index laws, so they're really important. I've mentioned a couple of times index laws, make sure you revise that, to bring that power down once I've logged it, okay? And I know that log base e, is just ln, so I know, and again, my form is ln, so I know I'm in the right track, okay? So ln of 1001 is equal to 0.5t, which is my power. I'm putting it to the front now, so I can do that with log laws, times ln of e. And I know ln of e is just 1 because, and I can make a proof for that, so y equals ln of e is equal to y equals log base e of e. If I convert it to index form, e to the power of y equals e, which is just, to the power of 1, so therefore y equals 1. And so that's why ln e is equal to 1, because that's equal to y. Right, so I'm just left with 0.5t. Okay. And I guess, if we want that form a ln b, then we know that we can manipulate this 0.5 to make it just half times t, or even better, just t over 2. I'm just timesing 2 on both sides now. So 2 ln 1001 to get t on its own. And so I would probably definitely make this as a word answer, because it's a word problem. So I'd say therefore it will take 2 ln 1001 days after the new post for the community group to achieve 7 times the initial number of members. Okay, so that's really a full, complete answer there. Okay, so that was method 2 of the question 17. That's definitely how I did it and how I learned it as well. Method 1 is really about taking an integral from 0 to m, where we let m be the time when 7,000 members is reached. So that can also be an interesting one. there, and I guess we're making the integral equal to 6,000 because that's the required change in members. So 1,000 to 7,000, that's an increase of 6,000. And so I guess mathematically speaking, that's like 6,000 would be the area under the curve, and that's the change. But um, personally, I find it quite easier to just do it this way. Um, yeah, but it's intuitive for me. So I learned it. So that's the method I'll just show here. You can definitely look at that, and I guess there's different marks for different methods, but you still get the full marks if you're working out for both methods fully. Either method works. So method 2 is what is shown here on the marking scheme, and so I'll go through a rundown of the marks. Like I did in the previous question. So for 3 marks, first mark was correctly determining the integral indefinitely, and then the definite integral, so determining C, and then obviously the last mark is the 2ln 1001, and I'm putting it in that form there. Okay, so we know that A equals 2 and B equals 1001. I might even mention that in my response as well, just to be really sure. Especially for sometimes the question may actually ask you to express your answer in the form A, ln B, giving the answers for A and B, and then you need to say this, otherwise you might technically be able to lose marks for that. Okay, so on to the complex unfamiliar part of the paper. So these last 2 questions. So for 5 marks, I think this is the question with the most marks. That's a single question. So you can see it goes through 2 pages. And I'm quite annoyed that I just reviewed this question, and I'm quite annoyed that I feel like I believe that I lost the like 50 out of 50, and I got a 49 out of 50 for the externals from this particular question. And I'm particularly annoyed because I feel like this was such an easy question to do. Easy, complex, unfamiliar question, but I think when I tried it on my own without looking at the marking guide, I think I might have fell into the same trap, but I don't exactly remember why I got the wrong answer. But I do particularly know that for all the questions that asked about the reasonableness or making a justified decision, I said unreasonable for all of them. So I'm quite annoyed that for some reason, I don't know, maybe exam pressure or anything like that got into the way, and I got this question inherently wrong, but I'm pretty sure I also got part marks, which is what also saved me to get really close to that 50 out of 50. So you can see here with 5 marks, you really have a lot of opportunity to gain at least, most of the marks. But I'll be showing you how to get full marks for this question, and it's actually not a bad one if you think. It looks complicated, but it's actually not too bad. So the diagram shows some dimensions of a large storage container that is a rectangular prism. The angle ABC is 60 degrees. So let's put that down immediately, straight away. A person requires a container that is at least 4 meters in height. Okay, so I've already wrote a lowercase h there, but that has to be at least 4 meters in height. Okay, that's the conditions. Make a justified decision, however, about whether this storage container meets the person's requirements. Okay, so let h equal the height of the rectangular prism. Okay, and in that case, we know that with rectangular prisms, we have right angles basically everywhere. Okay? So within this triangle, broken up into within the rectangular prism, there are right angles hidden everywhere. And so we can use Pythagoras' theorem to figure out that BC is going to be, we know that height here is going to be the other length, and so the hypotenuse is going to be C. In our formula, C squared equals A squared plus B squared, the hypotenuse theorem, so C was equal to the square root of A squared plus B squared. So we know that BC length is equal to the square root of those two sides squared and added together. So 4 squared plus h squared. Okay, which we know is going to be simplified to 16 plus h squared. Sorry, h squared. And because, let's say, the angle capital A is opposite to that side, we might let that equal to this lowercase capital A side. Okay, good. Now we know length AB on the triangle is again going to be using Pythagoras theorem. Square root of, we know this length is going to be moving this up. It's going to be equivalent 3 meters. And then this length here is going to be 4 meters. So we know that that's going to be the square root of 4 squared plus 3 squared, which we know that's a 3, 4, 5 triangle. And so the length is 5 there. And because, again, opposite angle C, so we'll let that equal to lowercase c. There. Actually, sorry, I might make that B. And the reason for that is because I'm going to use my cosine formula later. Actually, no, sorry. That's weird. The marking guide is wrong here. So yeah, it is C, sorry. Forget about what I just said before. So 5 is C. A is equal to square root of 16 plus h squared. And then I know that AC side is going to again be using that right angle triangle, so the Pythagoras theorem. So we have 3 as one of the sides and h as the other side. So that's going to be equal to square root of 9 plus h squared. My pen isn't working at the moment. Sorry, 9 plus square 9 plus h squared. And so that will be equal to and not working. Apologies here. Yes, yeah. That's going to be equal to side B because it's opposite the angle B, which we know is 60 degrees, okay? So what I might do with the cosine rule, because I have an angle and I have 3 sides, so that's a key indicator that I'm using the cosine rule for triangles. I might change my variables, so I know that it's in terms of C in the general formula, but I need to be using B instead because I know the angle of B. So I'll be using B squared, and then I might swap the B and C to get together. So I know that I'll be applying the cosine rule, so I'll write that out in my form for this question. So B squared equals the other side squared, adding them together, minus those two other sides, cos B. Okay, and this may have been where I slipped up, but I won't slip up in this explanation. So we know that B is, we know our A, B, and C values in our capital B is 60 degrees. Okay, so we're just substituting that in now. And what I like about this is that our square roots actually get canceled out most of the time. Okay, so I really don't know how I got this wrong, but sometimes that happens, which is why it's really important to take a stepwise approach and just, take this question as if it was not a complex, unfamiliar question, right? I guess the good thing about these exams, they don't really tell you whether they're complex, unfamiliar, what type of questions they are. Just treat every question normally, okay, how you would every question, right? Like this could easily be like a simple, familiar question if you've, you're confident, you get into the exam, you see this kind of question, you think to yourself, you can do this, you can get full marks, all right? So plus, and never leaves these questions blank as well. Like, I don't understand why some people leave questions blank, because you can definitely get hard marks and be the difference between a 45 out of 50 and a 49 out of 50, you know, which would be the same in my case. Okay. Okay, so I've just substituted in, right? But now time for the maths. So I'm just simplifying now. So everything that's in square root, if I'm squaring it, then I'm taking rid of the square root because it just cancels out, right? So just keeping it as it is, inside the square root, taking out the square root sign, and then just simplifying now. So 5 squared is 25 minus, okay, I might deal with these first. So cos 60 degrees, I know from my unit circle that 60 degrees is a bit more than 45 degrees, and so I'll be getting a smaller value on my x for the cos, and so that will be a half. So 2 times 16 plus h squared times 5 times a half. I have a 2 at the front here, and I'm timesing it by a half, so that eventually becomes 1. And so that just becomes 5 times the square root 16 plus h squared. So 9 plus h squared equals 16 plus h squared plus 25 minus 5 times square root of 16 plus h squared. And I think at this point I might have messed up because for some reason I ended up with h to the power of 4 the last time I did this, a couple of minutes ago. And I was a bit confused why they would put this on a complex, a tech-free paper, and the h to the power of 4 wasn't working with if we let like a equals h squared or something like that, and we did it that way. It doesn't work. It wasn't working with that, so I was very confused. But yeah, there's not going to be any. The highest power you'll get in this question, at least, is h squared. And then now it's just simplifying. So we have h squared and h squared on both sides, so we can get rid of that, which is really nice. 16 plus 25 is 41. There's a quick maths there. And 9 minus 41 will be negative 32. It's negative 5 times square root of 16 plus h squared. I have 2 negatives on both sides, so I can make them positive. So 32 equals 5 over square root of 16 plus h squared. I know that I'm trying to get h on its own. So 32 divided by 5 is, if I do that in long division, I get 630, and then minus those is 2 left, then 0 here. So 6.4, okay, equals square root of 16 plus h squared, okay? And then I will square 6.4, and then to get rid of the square root on the right-hand side. And then what we can do here now is minus 16 on both sides. So we're just going to get h on its own. So we're trying to find that expression for h, okay? So h squared equals 6.4 squared minus 16, and h is therefore equal to plus or minus the square root of 6.4 squared minus 16. But we reject negative value because h is length. Therefore, h is greater than 0 meters, right, in the container. So therefore, h is equal to the square root of 6.4 squared minus 16. Okay. Remember, when we're square rooting, technically, we have plus and minus. Okay, but I'm explaining why I'm choosing the positive value rather than the negative value. Okay, so that's that. And what we can do now is, if you don't want to do 6.4 squared because you haven't learned that or anything like that, I know I certainly can do that, and I might do that method as well. But firstly, I'll do the method that QCAA gives. We know that this value for h is going to be greater than the square root of 6 squared minus 16. Okay? So sometimes if we have decimals and we know everything has worked out perfectly, then we can use a relative scale using whole numbers and then using these inequalities like greater than to show our argument or statement, right? That is still factually true, okay? So we know that 6 squared is 36 minus 16 is 20, so it's square root of 20, okay? So essentially what I'm saying is that the height is going to be greater than square root of 20, okay? But since the square root of 16 is equal to 4 meters, in terms of meters, which is what the minimum height requirements that the person requires, then we know automatically that it's definitely, the height of the container definitely is going to be greater than 4, or the square root of 16, because we're doing that relative to square root of 20. We know the height is definitely greater than square root of 20, right? So basically, height, which is greater than square root of 20, which we've noticed from doing basically rounding down 6.4 to 6, height is greater than square root of 20, which is greater than square root of 16, which we know is equal to 4 meters. Okay, so what we're saying here is that the height of container is greater than the 4 meters required. Therefore, the container does meet the person's requirements. So that's where I lost the mark there last year on this external. Okay. And that cost me not getting 100% or the highest score on the mathematical methods 2024 QCAA subject. Okay, so it seems complicated, but it's really just using those formulas. Okay, substituting, using a bit of maths, and I'll show you my method 2 that I did a couple of minutes ago. I actually did 6.4 squared, and the technique to do that is to actually do 64 squared, but then divide it by the 100 or the 2, I guess, because there's 2 zeros that we multiplied by for both numbers, right? So basically what I'm saying is 6.4 times 6.4 can be the same as just timesing that by 100. So we have 64 times 64 because we moved it to one decimal place for both numbers, 64 times 64, and then dividing by 100, or just like moving the decimal point back there, and then we're using methods from primary school, high school, early high school to make using arithmetic here. I believe it's 36, 24, 36. Yeah, got that right. So 40.96 there. Okay, is my answer. Okay, so I might do that slowly for people who need to refresh. So I first take this number and I multiply it by 64, so 16. So I put the 1 out here. 6 times 4 is 24, times plus 1 is 25. Okay, and I start from here now. Okay, so I leave a 0 here because I'm using this number now. Sorry, I'm using this number now, the 6. I'm timing it by 64. So I'm using 6 times 4, so 24, so put the 4 down, put the 2 up. 36 plus 2 is 38. Okay, and I'm just adding now. Okay, so 6 plus nothing is 6, 5 plus 4 is 9, 2 plus 8 is 0, and 2 plus 8 is 10, which is put the 10, 1, carry the 1 tens on the next number, so 1 plus 3 is 4. And then I move my 2 decimal places that I times by 100 before to get to 40.96. Okay, so I know 6.4 squared is 40.96, but in terms of our question, again, h is equal to, looking up here, 6.4 squared minus 16. So I need to minus 16 from that. So square root of 40.96 minus 16. And in my head, I know that's going to be 24.96. And the reason I was so annoyed is because that's so close to the square root of 25, because 24.96 very close to 25, and the square root of 25 is 5. So it was also basically a giver question. It wasn't that difficult, you know, especially for me, but I got that wrong because I honestly don't know why, but at least you know that sometimes mistakes may happen, but you need to have a clear mind and a really, I guess, these unfamiliar questions you've never seen before, they just use the same maths that you've been using all along, okay? But you may need to revise a couple of things and be really good with your multiplication and all that, or you may need to use a bit of outside the box thinking by, making that greater than 6 squared minus 16, those sort of things, okay, to get the answer. So just a rundown of the marks. First mark is calculating what the length BC is, and the second mark is calculating what AC is, okay, in terms of height. Note that I don't get the mark for AB because, I guess it's just given. It's Pythagoras. We learned that in year 9, I believe. But it's really about using our assumption of letting h equal the height of the rectangular prism and including that in our equations. The third mark is getting to this point here where we find out what an expression for the height of the container, and then our fourth mark is deciding that the container does meet the person's requirements, and then the fifth mark is sort of like a hidden mark, but it's really just everything here in terms of our logical organization, communicating key steps. Okay, so I could have done a better job with that. I feel like by saying, for example, using cosine rule, okay, that would have been part of the mark. And maybe putting more units down, but really, it really depends on the marker, but as long as it's a logical approach and they can follow you working out, I'm pretty sure you'll just get that fifth mark anyway, so it's sort of a given fifth mark there. But yeah, just really be detailed. I would definitely, write down Pythagoras theorem if I need to, show every bit of working out. I know it's here, but, making sure it's in the line just to be safe. But really making sure that it looks really neat and it flows well. You're not going from the bottom left to the top right and then putting so many arrows and stuff like that, making it confusing for the marker, okay? So making it neat is really just that fifth mark. So yeah, I guess in a way neatness can also help give you those marks, and I'm sure in my external I got that mark. Even though I may get the answer wrong, just my neatness and my organization of my working, making sure I'm doing it vertically and everything, and showing every bit of working that I'm doing is just giving me that marks, like it's a free mark, honestly. Okay, so now we are on the last question. A permanent ice glacier is in a valley in New Zealand. So that's some context. Due to the temperature changes of the seasons each year, the glacier expands for 6 months and recedes for 6 months. Okay, so if you think about in a year, if we have our graph, right, then we may have something where we are expanding in size, and then after 6 months it decreases in size. Okay. The changing distance of a point of the front edge of the glacier to a car park can be modeled by a sine function. So we know we'll be using sine. During the colder months, when the glacier expands, the front edge of the glacier moves to within 270 meters of the car park. However, in the warmer months, when the glacier recedes, the front edge moves to a maximum distance of 280 meters away from the car park. Okay. The erosion effects of the glacier on the ground are of most interest to geologists when the absolute value of the acceleration of the front edge is greater than this value here in meters per month squared. During these times, a team of geologists sets up a campsite nearby to perform field work. Whenever the acceleration is less than this, then the geologists leave the camp. The following claim is made. The geologists will spend a total of between 7 and 8 months at the campsite each calendar year. Evaluate the reasonableness of this claim. Okay, so for this question, we really have to note a couple of things, that we have a periodic motion within this word problem hidden. It's sort of in between the lines that we need to create a sine function, such as like a graph like this, essentially, or try and model that using the information we have. So the periodic function can be modeled by a sine function. Okay, so if we remember our sine function, our general formula for it, where we say maybe g will be the glacier in terms of time, okay, throughout the calendar year, is equal to the amplitude, say capital A, times sine, and then we have our b value in front, and then we have x plus c, which is our translation, and plus d, which is going to be our I guess our equilibrium or midline, sort of halfway between the max and min values. Okay, so if we know that the front edge of the glacier moves to within 270 meters of the car park up to a maximum distance of 280, we know our max is 280 meters during the warmer months, but in the colder months, when that glacier really expands, then that front edge will move to within 270 meters. So that's the minimum. Okay, so from that, what we can do is we can get the d value, which will be the halfway between 270 and 280, which we can calculate by adding them together and dividing by 2. So that will give us 275 meters, because if we do 270 plus 280, that will be 550 divided by 2 will be 275, or it's just essentially just the number between them. So that's pretty easy, I'd say, to know the halfway point. And then our amplitude, we know from that, will be just the max minus the d, which will be 280 minus 275, which is just 5 meters, right? Because we know that if we have a midpoint line, so just drawing a graph here of a sine function, if our midpoint here is that 275 line and we got a 280 max, then we know the amplitude is just going to be 5 meters. Okay. And then we also know another formula. I don't know if it's on the formula sheet. I might check. No, it is not on the formula sheet, so you'll have to memorize this in case I haven't seen it there. Then the formula for our period, which is capital T, so note the difference between lowercase t, time, and period, capital T, is equal to 2 pi over capital B, which is our dilation factor on the x here. Okay, so rearranging to find B, we know that period is equal to 12 months. Okay, so because the claim is in terms of months, so let's work with months in terms of time. So 2 pi over 12, so that's going to be simplified to pi on 6 as our B value, okay? And then C, not necessarily any shift in this context, so that'll just be 0. Okay, so we have a simple sine function, so apologies there. Therefore, the function of glacier in terms of time is 5, which is our A value, amplitude, sine pi on 6, which is our B value, times t, plus 275, okay, which is our D value there. All right, so that is our first mark, which is to correctly determine the sine function that models the front edge of the glacier position. All right, and then the second part is really about moving on to differentiating, okay? So we need to now find the velocity or the derivative of the displacement function by using our formula. So we know differentiating sine in our formula is just turning it into a cos and taking that B value on the outside now. So we're taking 5 times pi on 6 cos and keep everything the same in there. And then this 275 on the back is really just gonna disappear because it's a constant, and differentiating a constant will essentially just make the constants disappear and become 0, right? So we have that now. Okay, and then once we found the velocity function, we get a tick for that. Okay, and then our third mark, so this is 6 marks actually, that's the question with the most marks, makes sense as the last question. G dash dash of x is going to be, remember taking the derivative of a cos function is going to make the value negative, so negative, and then take that pi on 6 out and multiply it by the 5 pi on 6 value there. Okay, and then turn it to sine and keep everything the same as well inside the brackets. Apologies. Okay, and then I'll get negative 5 pi squared because I have 2 pi multiplied together over 36. And that'll be sine pi over 6t. Okay, and then that will be our third mark, which is, find the acceleration or the second derivative of the front edge of the glacier. And now we got to look back into what our question is saying. We know that when the acceleration of the front edge, so basically this function, is greater than 5 pi squared times square root of 3 all over 72 is, so when our function is greater than that acceleration value, then the geologists are going to be there, okay? So we need to solve for t, lowercase t, which is time, okay? So in this case here, we need to take note that the acceleration, the absolute value of the acceleration can be derived from both a positive and a negative value, right? So essentially what we're doing is we're now equating acceleration to 5 pi squared on times 3 on 72, or negative that value because we know we can be going up or increasing in our front edge of the glacier or decreasing. But we know that because the question is asking about the absolute acceleration, then we need to be considering both positives and negatives here, right? So let's see. So we know with our function here with the negative 5 pi squared on 36 sine pi over 6 t, if we just let that equal to each of these two accelerations and then sort of find the distance between our two t values, then we can note what time the geologist will be there in each, I guess, interval, right? Because if you think of this visually, right, there's our midline, horizontal midline there. Sorry, I'll just do one period of this. If the acceleration of this function, which is still a sine function, right? Well, it's a negative sine function, but just pretend it's just a normal sine function. What I'm really trying to say is that at a particular point, which is our 5 pi squared on root times root 3 all over 72, we're going to have two time intervals when that glacier acceleration meets that, okay? For example, and then the distance between these two times here, t1 and t2, that distance is going to be how long the glacier acceleration is going to be greater than what this value is, and I've highlighted in green. And so that's how long the geologists are going to be there for. Okay, but we need to take into account both the when they're accelerating positively and also accelerating, I guess decelerating or like accelerating in a negative direction, which will also be the negative version here. So negative 5 pi squared over 3 over 72. Even though these two values are negative here, we still have to take those into account because we're talking about, in the question, the absolute value of the acceleration. Okay, so when the glacier is here, then that's when the acceleration or the absolute value of the acceleration is greater than this value here in green. Okay, but that negative there, I shall show in yellow, is just giving a sense of direction, but in this question it's not significant. So we take both values there and then we add those times up between those differences here. So we essentially find the difference between T1 and T2 and then find a distance between T3 and T4 and then add those two differences together. Okay, so we're adding these two distances of time intervals of how long the geologist will be there for together, and then comparing that with the claim to evaluate the reasonableness of it. Okay, so first off, let's start off with the positive value. Okay, so we know that the acceleration is going to be, let's let it be equal to that I guess boundary or sort of like minimum acceleration we need to meet first, and then we'll make that equal to our function we found out before. Okay, and we sort of have to, I guess, get t on its own. So what I would do is I would take rid of the 5 pi squared because that's common on both of them. So I can essentially divide by 5 pi squared on both sides. So I'm left with square root 3 on 72 equals -1. So remember that negative over 36. I would probably times by -36 on both sides now. So that will give me just 1 here then. And then I'll be left with my sun function only. So that gets rid of that. And then I'll be left with square root of 3 over 2, but that's a negative value because I'm timesing by a negative with a positive because 36 is half of 72 there. Okay, and then equals to sine pi over 6t. Okay, and then from that, I need to be thinking about my unit circle and think about which values of sine, which is our y values, are going to be negative, right? So if we use CAST acronym, we know that sine is going to be negative on where there's tan is positive and where cos is positive as well. Only cos is positive. Okay, and so essentially it makes sense because the y values on the first and fourth quadrants, sorry, the 1, 2, 3, fourth and this is the fourth quadrant and the third quadrant. If this is the first quadrant, I might have forgotten, but anyway, what matters is that below the x-axis we have our sine values, or the y value is going to be negative. Okay, so yeah, basically we know that we're working with the bottom left and the bottom right quadrant. Okay, and we need to have a value of square root 3 on 2. Okay, that negative just tells us which quadrant we are, but the absolute value again is telling us what angle, or I guess we can make the angle in terms of radians that we're dealing with here. Okay, so, and we'll just keep it as positive angles, if that makes sense. So again, with my unit circle, I know that a full half revolution is just pi. Okay, so I'm going to be working on values over pi. So the value here in this bottom left quadrant is, if I want sine to be square root 3 on 2, which is going to be a higher value, I'm going to want a higher angle here, greater than pi on 4. So that's going to be 4 pi on 3. Okay, and if radians or pi doesn't really necessarily work for you, try and work with degrees first. So what I would do is I would, I know that pi is equal to 180, right? And I know a half revolution is 180 degrees, right? So the only real, I guess, values with the I guess common triangles, common right angle triangles, is we have, what was it, 1 square root 3, 2. Okay, I know that 60 degrees is going to be opposite of the larger value, and then 30 degrees will be opposite of the smaller value, right? So that means my sine of 60 degrees is going to be equal to square root over 3 over 2, and my sine of the 30 degrees is going to be my 1 over 2, right? So I know, because I'm working with square roots of 3's, I need to be working with a sine 60 degrees relative to my quadrants. Okay, and I know that pi is 180 degrees, so in terms of 60 degrees, that's just a third. So I'm working with sine pi on 3, okay? But because I'm in the third quadrant, I've already done 1 pi half revolution. Then I'm doing pi plus pi over 3, which in this case, if pi is just pi over 1, then I can make it as the same denominator and add by pi over 3, which will equal 4 pi over 3. Okay, and so that's now the angle that I'm using for this this bottom left quadrant here, okay? So essentially what I'm doing is taking the sine inverse of both sides, but that's how I do it. I'm trying to find what angle in radians, perhaps because I'm working with pi's, so I'll be working with radians here. Do I need to, I guess, take the sine of to get a value of negative square root 3 on 2? That's what I'm getting at here. So that means everything in the brackets, which is my angle part, pi over 6 times t, is equal to 4 pi over 3. Or I have another value which is in the bottom right quadrant. And if you think about how this is going to be 60 degrees, or pi over 3, then if I have a full 2 pi revolution, then I'm just taking away that pi over 3 that I need to take back from revolving, right? Because if you think about it, I've done a full revolution here, which is 2 pi, but I've revolved around too much. I need to only be at this point. Okay, so I have a pi on 3 or a 60-degree angle there. I know that's going to be my y or sine value because that's going to be opposite that angle. And so I'm just taking away the pi over 3 that I don't have to revolve around. So that would be 2 pi minus pi over 3. Again, using those fraction skills, that's going to be 6 pi over 3 minus pi over 3, which is 5 pi over 3. Okay. And now what I can do is I can work with these values now. I have two values for pi over 6 times t, and then I can just simplify, rearrange the equation to get t on its own. So I can multiply by 6 on both sides, so I have left with pi t equals, this will be, so 6 is double 3, so I'm going to be working with 8 pi now, or times by 6 on this fraction, I'll be working with 5 pi times 2, or 10 pi. Okay, and because pi t, to get t on its own, I just need to divide by pi, so all the numbers will no longer have pi, okay? And I'm working in months, so remember that, units, right? Now remember, when I'm putting it into context of the equation, the context of the question, I basically calculated those 8 to 10 months down here, basically, okay? Or in terms of a proper sine function that's negative, draw a proper negative sine function, my apologies. It'll be a negative sine function that will be like this, okay? Because I use my positive 5 pi squared times square root of 3 all over 72, then I'm calculating something, I guess, in the second half of the calendar year. So that 8 to 10 months seems reasonable. So this is 8, this is 10 months. Obviously, it's not the scale, but it's just saying that we have calculated those intercepts, essentially, with this line here for the minimum absolute acceleration that the geologist will be sitting and waiting at the camp, basically, or like analyzing or doing whatever they're doing, performing field work, essentially, okay? So we need to calculate the distance between those, okay? Because we can't just calculate time and say that's our answer. We need to calculate the distance, because that gives us the total amount of time that they are basically spending at the campsite each calendar year, right? So again, This is what I was saying. This is our t1, this is our t2. The distance between that is what we're trying to find. So 8 to 10, that's simple, just 2 months. Okay, so in here we have 2-month period of time, okay, as one of our factors there. But then we also need to consider again this one now, so the negative version. Okay, so again, I'll just be repeating my steps here, but with negatives. So negative 5 pi squared square 3 2 equal negative 5 pi squared over 36 9 pi over 6t. Okay, again, I have both negatives on both sides, so I can take them away, make them positives now, take away the 5 pi squared. So I'm left with just this. And then multiply with 36 on both sides. I'm going to be left with my square root of 3 on 2 equals sine pi over 6t. Again, unit circle, I have a positive value for sine, so when I'm going to be above my x-axis, and then I'll be working with square root 3 over 2 as opposed to 1 over 2, so sine will be a greater value, so 60 degrees or pi on 3, and then there'll be a pi on 3 as well here, so that'll be simply pi over 6t, which is my inside bracket, so the angle is going to be pi on 3, or in here I have done a full half revolution. I've done a half revolution and then I revolved around too much, so I need to go back by pi over 3. Okay, so in this case, again, pi over 1 times 3 on top and bottom is 3 pi over 3, minus that pi over 3 is 2 pi on 3. Okay, and then multiplying by 6 on both sides for each number, pi t equals 6. This will be double 2 pi, or times by 6 here, that'll be 4 pi, and then t is equal to 2 or 4 months. Okay, and that will be, again, we're looking at our graph. This is 2 months here, and this is 4 months, again, not to scale, but the distance between them, again, between T3 and T4 is going to be 2 months. So we have a 2-month period of time. Okay, and then now what we say is that we can draw an arrow to show our working. Maybe draw a division here so we know that we can show where the marker can follow our working. Therefore, the acceleration will be greater than the given absolute value for a total of 2 plus 2 equals 4 months in a year. Again, because it's tech free, I know I'm doing something right because I'm working with really easy numbers, and that's literally, quite funnily and quite literally, our 4th mark, I believe, is yeah, that will be one of our marks though. Yes, so that would be one of the marks, literally doing 2 plus 2 equals 4. Right, crazy, right, on the Maths Methods external exam paper. But really, it's just about determining the sum of the 2 possible time periods when acceleration is greater than the absolute value given. And then saying, always remember, to answer the question, which is the cognitive verb here is evaluate reasonableness of the claim. Basically just say, therefore, the claim is not reasonable as 4 months is less than the stated between, what was the claim? Between 7 and 8 months mentioned in the claim. Okay, so you get that mark for saying the claim is not reasonable. Now I've only ticked 5 ticks there, even though it's a 6-mark question, but we do have full marks in this working out because that other mark, the missing mark, is basically when we had that 2-month period. So figuring out the difference between those times gives us the mark. Okay, so basically finding that difference, again, as I was mentioning, the T1 to T2 and the T3 to T4, that gives us the mark for that. Okay, because we need to determine a period of time in a year where the acceleration is greater than the value given, and that is our mark there. So that's a total of 6 marks. So that's a 100% paper right there, all done there for you. And that's the last question there. All right, so thank you for watching. If you have any questions or would you like me to do a specific question or a paper, please let me know in the comments or text me on my Instagram, Louis Galman. And I do have a link to all my working out for all my subjects here that I do on my YouTube channel on the description box below. So please check it out, and thank you, and I hope you've learned something from this. Cheers.